So now we're going to start working through the development of the cap plus pricing model. We kind of laid the framework. Uh, so the relationship between expected return and risk, being the CAPM, the expected return on the market. Here is, yeah, that would, R bar M is equal to the risk-free rate plus the market risk premium. With market risk premium is simply the expected return on the market minus the risk-free rate. So the expected return on an individual security is so R bar with little I is equal to the risk-free rate uh, plus beta for that security, for the individual security, multiplied by the expected return on the market minus the risk-free rate. That is the market risk premium. So this just so the expected return on the market minus the risk-free rate. It's a market risk premium. So make sure you differentiate between the expected return on the market and the market risk premium. So because some calculations will give you the expected return on the market, others will give you the market risk premium. So if you use the wrong one, you'll calculate the incorrect answer. So again, market risk premium. So applies to individual securities held within a well-diversified portfolio. So, but again, continue with expected return on security or capital asset pricing model, or CAPM. The expected return on security I is equal to the risk-free rate plus beta for that security multiplied by the market risk premium. So if beta is 0, then the expected return on the security is the risk-free rate. So beta 0 implies no risk or no reaction to a change in the market. Beta equal to 1, then the return on that security is going to equal the return on the market, or the expected return. So relationship between risk and return. So the expected return in this case is going to be a straight line. We graph against beta and expected return. So the market portfolio has a beta of 1, and it's given expected return. The if the beta is greater than 1, the expected return is going to be greater than the market. If the beta is less than 1, the expected return is going to be less than the market. So simple as that. Example on the next slide. We got a beta here. Stuck with a beta of 1.5. So if our return on the market is 10, then if we go back to our previous, so that we had, this was 10 here, and so we go to the next, back to the next slide. So we take our risk-free rate of 3%, we add it to our beta 1.5 times 10 minus the risk-free rate, and we get 13.5%. So remember that our market portfolio, not very well drawn, but this is how the capital asset pricing model works. So if just to take a little bit of an aside here, if the expected return on the security was actually say it was 15%, then that security would be said to have a positive alpha. So alpha greater than 0. If the expected return on this security was down here, say it was 8%, that would be an alpha less than 0. That would be a negative alpha. The um, so the that is the end of the lecture. Walk through the quick quiz for this chapter. How do you compute the expected return and standard deviation for an individual asset? You take all the possible outcomes and multiply them by their probabilities, and you sum those up. And then standard deviation is you take the probabilities and you multiply them by the outcomes minus the expected return, and you square them and sum them up. And take the square root of that. It gives you the standard deviation. And you basically do the same thing for portfolio. We take the individual weights. There are some special cases of formulas that we talked about in earlier lectures. So, difference between systematic and unsystematic risk. Systematic risk is the market risk. That's a risk that cannot be diversified away. Unsystematic risk is firm-specific and industry-specific risk that can be diversified away. So which type is more relevant for determining expected return? Systematic risk, because you cannot diversify that risk away. So, just an example here, we've got an asset with a beta of 1.2 and a risk-free rate of 13. So what is the expected return on this security? So we would write it out like this. If I get there someday, there we go. So the return on security I is going to be equal to the risk-free rate plus beta multiplied by the expected return on the market of 13% minus 5. That gives us an expected return of 14.6%. Again, take the risk-free rate, add it to beta, multiplied by the market risk premium. That's the expected return on the market minus the risk-free rate. And it gives us an expected return for security I of 14.6%.